In this session, we will discuss the suggested standard nomenclature to be used in monitoring a hazard in the urban search and rescue environment. We will discuss recording of data both by handwritten notes on the approved FEMA forms and in the personal field notebook. We will also discuss electronic recording within the total station instrument. It is believed that by utilizing a standard labeling system, confusion can be minimized or avoided when the structure specialist is documenting and communicating important information. There are three primary types of data points that are associated with monitoring hazards in an urban search and rescue environment. These types of data points are control points, used to create a coordinate grid system of the rescue site; instrument points, location of the instrument when monitoring a hazard; monitor points, points of a hazard that can be monitored for displacement. It is important to note the data points are both numbered and named in this proposed system. First, we are going to discuss the numbering convention that is proposed for the data points. Control points are to be numbered in increments of 10. The first control point, or CP, is numbered 10, the second 20, the third 30, and so on. It is important to identify control points that are not directly associated with or won't be affected by the hazard you are monitoring. Control points are reference points that will be used to establish the grid coordinate system of the site and may be needed to verify accuracy or re-establish the coordinate grid after the instrument is relocated. Therefore, it is critical to locate control points in semi-permanent areas that are visible to any location that the instrument may need to be relocated to. Finally, it is better to have control points spaced significantly apart so that if the instrument is relocated, it can triangulate on the new location. Instrument points, or IPs, are numbered in increments of 1. Typically, the first control point is the first instrument point as well. This means that the first instrument point, or IP, is often numbered 10. If the instrument is required to be relocated to a new instrument location, and this new location is not a control point, the point number for the second IP is 11. Backsites associated with each new IP station are numbered 5 off of the IP number. For example, point 10, which is IP1, would be associated with backsite point 15. Point 11, which is IP2, would be associated with backsite point number 16. The third type of data used in the urban search and rescue monitoring plan is the monitor point. Monitor points are numbered in the hundreds. For example, the initial measurement of the first MP is numbered 100. Subsequent measurements of this same MP are incremented by 1. Thus, 101 is the second measurement of the first MP, 102 is the third measurement, and so on. Now we will discuss the naming conventions for the three types of data points associated with monitoring in an urban search and rescue environment. These names will be used in the field book, or on the monitoring forms under description, or in the CD input line of the total station when electronically measuring and recording data. Control points are labeled CP, followed by a 2-digit number designator. Control points are labeled in increments of 10, so the first CP is labeled CP10, the second CP20, and the third CP30, and so on. Typically, the first control point is the first instrument point as well, and this point will have additional label descriptors inserted. Instrument points are the location of the instrument when monitoring a hazard and are labeled IP, followed by a 1-digit number designator. Instrument points are incremented by 1, so the first IP is labeled IP1, the second IP2, and the third IP3, and so on. As stated previously, IPs are typically specifically designated control points used when establishing the grid coordinate system. Therefore, the first control point, or CP, is usually the first IP, so the labeling convention would be CP10-IP1. After the coordinate grid has been established, it may be necessary to relocate the instrument to another location. It is not necessary to relocate to an existing control point if at least two of the control points within the coordinate system can be measured from the new location. In this case, the label designator for the new IP would be IP2 with no CP prefix. An example is that the IP has been relocated to the third control point location. In this case, the CP30 designator would be modified to read CP30-IP2. Monitoring points are labeled by increments of 100. The first MP is MP100, the second MP200, the third MP300, and so on. The names of the monitor points do not change with each measurement taken. It is important to remember that the numbering of each recorded measurement does. The main considerations for the three types of data points are that monitor points should be observable from a safe distance and the expected displacement should be fully understood by the structure specialist. Control and instrument points should be semi-permanent locations that provide full visibility of the monitoring locations. These points should be protected from disturbance by rescue operations or other activities that may occur on a rescue site. We will now discuss recording data by hand on either the FEMA-approved monitor forms or a personal field notebook carried by the structure specialist. Field notes for monitoring are critical communication information. Since monitoring is often continued from shift to shift through a prolonged operation period, monitoring forms need to be maintained and turned in by the STS at the end of each shift. These forms are located in your Field Operations Guide on disasterengineer.org and on this training disc. It is important to note that the filled-out forms will become part of FEMA's permanent record of the event. It is recommended that each structure specialist maintain a personal field book to be used as a personal journal of monitoring duties performed during an event. This field book will remain with the STS and could be used to provide backup documentation should the need arise. There are 4 primary FEMA-approved monitor forms. These forms are sized such that an 8.5 by 11 sheet can be folded in half and used on a pilot's kneeboard that is part of the STS cache. These 4 monitor forms will remain with the instrument, with copies being delivered to the IST at the end of each operational shift. The 4 forms are Mon 1, which is used to record instrument point, control point, and monitor point data. This form also provides space for an overall sketch of the rescue site or additional notes. Mon 2, which is used to record additional instrument point, control point, and monitor point data, and provides space for additional notes or sketches. CP log, which is used to record control point data when the control points are checked or the coordinate grid system is validated. A new CP log will be created for each operational period. Mon log, which is used to record monitor point data each time the monitoring points are measured. The measurement intervals should be timed such that the overall behavior pattern of the monitored hazard can be adequately determined. A new Mon log should be created for each operational period, though all the logs should be readily available to validate the behavior of the hazard. The following slides provide more detailed explanation of the monitor forms and field books, as well as filled-out examples of a monitor plan. The Mon 1 form is fairly self-explanatory as to the information that should be recorded. First, list monitor's name and the date and time that the operational period begins. Then, provide the monitored structure's identification information. Note the numbers of stories and if the structure contains subterranean features such as a basement or tunnel space. Next, note any weather or environmental information that may affect the behavior of the monitored hazard. The next block is for information on the instrument used for monitoring. If the total station is used, place the model name and serial number, as well as any calibration data that you may have. Also, list the job name used within the total station and the instrument point coordinates. Then, list the control point information. It is desired to have at least 3 distinct CP locations identified which will assist in reestablishing the grid coordinate system should the need arise. Finally, list any data pertaining to the monitored hazard, including an estimate of the alert displacement, when you will contact someone on the radio to discuss the displacement, and the alarm displacement, when you will sound the evacuation or warning alarm. Finally, sketch as much information about the monitored site that you can clearly identify. This would include physical structures, CP, IP, and MP locations, as well as a detailed graphical representation of what the data points look like through the instrument telescope. Be sure to relate the sketch to the designated controls that have been established at the site. For example, labeling the structure with the A, B, C, and D sides that all rescue personnel will refer to. Here is a filled-out Mon Log form for a monitor plan. Note the data fields that are filled in and the level of detail of that information. It is important to note that you want this information to clearly relay the monitor plan, even if you have been called to another task, and all that is remaining is this document. Note the information represented in the sketch as well. The structure has been labeled the same as other rescue personnel would be using. The locations of the IP, CP, and MP are all noted, as well as details of how these points appear in the instrument telescope. As stated earlier, Mon 2 is the form that provides additional information on the monitor plan. This sheet will contain additional instrument locations or control points, as well as additional notes or diagrams that would clearly relay information. Once again, here is a filled-out example of the use of this form. Note the information provided about the relocated instrument, including the coordinates, description, and even the reason the IP had to be relocated. This form also provides information on which control points were used to reestablish the grid coordinate system based on this new IP location. The CP log form is used to document additional measurements of the control points. These measurements are taken at sporadic intervals to validate that the grid coordinate system is still valid. Slight displacement in these measurements will also assist the STS in determining if displacement in the monitored hazard is true of a result of a shift in the coordinate system. Here is a filled-out example of the use of this form. Note the additional data information of horizontal angle and slope distance. These are data that are available to any theodolite instrument, but can act as reinforcement when utilizing the instrument as a total station as well. The Mon Log form is the detailed data record of the behavior of the hazard. It should be noted that each monitored hazard will have its own Mon Log form. Also, note that this form contains blank headings in the Readings column and can be used to record total station or theodolite readings. Note on the filled-out form that there was slight displacement in the hazard. The apparent cause of this displacement is noted for each instrument. The relocation of the instrument is also clearly indicated, as is the information that the instrument was bumped, which could result in displacement readings. Note that this form is for the second monitored hazard. In review, the FEMA-approved monitoring forms always remain with the instrument, except when they are being copied and handed in for inclusion into the Operation Activity Plan at the end of each shift. They become a permanent record of the event and include as much information as required to adequately provide such a record. Now we will discuss recording monitor data into the Structure Specialist Field Book. The Field Book should be a Write in the Rain or equivalent book and are located in the STS cache. The book should have columns on the left side pages and a grid on the right. These books often have pre-numbered pages. The first page of the book should be the table of contents. It should include the index of the information contained in the subsequent pages. The next 2 pages should include the incident name, date, and time, weather, including temperature and pressure if available, the STS name and task force in case the book is lost. This page should also include the instrument information, including the model name, serial number, and job information. Data recording of monitoring begins on pages 4 and 5 with the instrument and control points. The columns on the left-facing pages should have headings of horizontal angle, HA, distance, D, vertical angle, VA, X, Y, Z. The grid on the right-facing page is reserved for sketches of the building being monitored, sketches of instrument location, control points, monitoring points, and written descriptions of point numbers. Once the instrument is set up and control points are recorded, the following pages are used for the monitoring points. Note that each monitor point has its own pages for data recording. Columns are again HA, D, VA, X, Y, Z, time, instrument station location. Reading number starts at 100, next is 101, 102, 103, etc. The remaining grid area is reserved for a sketch of the monitoring point and how the crosshairs are being aligned on the target. In review, the field book remains with the structure specialist and is his or her primary backup in case of missing or damaged information from the monitor forms. It is not handed to the IST unless copies of the pages are made. Once again, it should contain as much information as is required to adequately relay the required data information. Now we will discuss recording the monitor data electronically in the Nikon NPL 352 total station instrument. This data recording utilizes the same nomenclature convention that we established for handwritten data recording. Numbering of the data points is the same, and the naming convention is also the same. It is merely that you must input the data correctly into the instrument. This specific procedure is described elsewhere in this training video. We are focusing on the nomenclature convention for this lesson. The following slides will discuss this procedure. After creating a job in the instrument, you will be required to create the first station or instrument point, IP. The first IP is numbered 10 and is located at coordinate 1000, 100, 10. It is the first control point or CP and is named CP10-IP1. As each line is highlighted, you will utilize the keypad on the instrument to type in the data. Our primary mission is to monitor a hazard. Therefore, the first thing you should do once you have the instrument set up is to take a baseline measurement of the monitor point. Again, monitor points are numbered in the hundreds, and each subsequent measurement point number is incremented by 1, while the name remains the same for each MP. Once the first couple of monitor points are recorded, it is time to start establishing control points, should you be required to relocate, or just to validate displacement information from the MP measurements. Control points are numbered in the tens, and the names are also changed for each entry. Typically, repeated measurements are not required to be recorded for the CP data. If it becomes necessary to relocate the instrument over a point that has not been previously established as a control point, this new IP is labeled IP2 numbered differently and wouldn't include the CP prefix. For example, this new IP is the second IP, so it is IP2 and the coordinates have been established by triangulating on 2 control points. A procedure described elsewhere in this video. The name input into the CD field is IP2 and the number assigned is point number 15. When recalling the internally stored data from the NPL 352, press the key labeled DAT or number 6 key on the keypad. The raw data information will be displayed along with the CD names that were input for each. The exceptions to this display are the current instrument station and backsite. This information can be displayed by highlighting the data point and pressing the key labeled ENT. Then press the key labeled DSP and page through the data information. In review, we have discussed the standard nomenclature used in monitoring hazards in the urban search and rescue environment. We discussed control points named CP and their numbering scheme. We also discussed instrument points or IPs and their numbering, as well as monitor points, MPs, and how they are named once, but numbered sequentially for each recorded measurement taken. We also discussed utilizing this nomenclature in various forms of recording methods. Handwritten recording methods centered around the FEMA-approved monitor forms and personal journal-type documentation in the Structure Specialist Field Book. We discussed which forms of written documentation remains with the instrument and gets turned in to the IST to become part of the permanent record, as well as keeping a personal copy for backup purposes. We discussed inputting this same type of data electronically into the Nikon NPL 352 and how we can retrieve that data if required. The primary points to be remembered here are that we must record as much information as required, and through the use of standardized nomenclature, we can reduce the communication errors that may exist in a very hectic rescue site. This concludes the note-taking lesson of the Total Station Training video disc.